try something. I will ask AI to prepare a short summary for my project update, send it to my manager, and it just did it. It created the summary, picked the key point, and even sent the message. So it didn't just generate content, it actually completed the task. Pretty powerful, right? But what just happened here? How did AI go from writing text to make decisions and taking actions? If you are wondering that, you are in the right place. Hi, I'm Sarah Alali, a senior technical trainer at Microsoft, specializing in AI, Copilot, and building intelligent and secure applications on Microsoft Azure. I have a PhD in computer science and 12 years teaching training experience. This course covers 12 sessions, where we will dive into core AI concepts in Azure and learn how to turn ideas into real application using modern tools like Microsoft Foundry. In the third session, we will cover an introduction to generative AI and agents, where we will explore generative AI and how it evolves into intelligent agents that can go beyond answering questions and actually get the work done. In the previous session, we talked about how applications connect to AI and how Microsoft Foundry helps us build intelligent solutions. Now let's talk about what kind of AI we are using in most modern applications. Generative AI. So what is generative AI? Generative AI is a type of artificial intelligence that creates new content. It doesn't just look things up or follow fixed rules. It generates something new every time based on your input. So, how generative AI works in the simplest way? First, you write a prompt in a natural language. Second, the AI understands your intent. Finally, third, it generates a response on the fly. That's it. That's the core idea behind generative AI. You don't pick from a menu. You don't follow a fixed workflow. You just ask and the AI creates something new every time. Let's make that concrete. Generative AI can produce many types of output. It can generate texts, like answers, summaries, emails, or maybe stories. It can generate speech, like turning text into a natural-sounding voice. It can also generate images, like creating pictures from description, creating videos, or videos like generating or enhancing animation and clips. And finally, it can generate code, like Python, C#, SQL, JavaScript, and more. For example, you ask, write a professional email asking for a project update. The AI generates a brand new email, no templates, no copy-paste, or you maybe can ask it, create a short story for children about a brave cat. Every person who asks gets a different story. That's how generative AI works. Most generative AI you interact with is powered by language models. We have large language models, or LLMs. LLMs are very powerful models trained on a huge amount of text. They understand language, context, tone, and intent. For example, you ask an AI assistant, summarize this long document in 3 bullet points. What the model is going to do is going to read, understand, and create a brand new summary. Also, small language models, or SLMs, work in a similar way, but are lighter and faster. They are useful when you want lower cost, faster responses, or to run closer to the device. Example, a help assistant embedded in an internal app that answers simple HR questions quickly. Both models, LLMs and SLMs, are generative because they create response, not select from a list. Let's look at some of the everyday applications for generative AI listed on this slide. Think of a smart chatbot, which they are not like traditional chatbot. They don't rely on a hard-coded answers. They respond dynamically to customers' questions. Or maybe creative AI assistant that will write marketing copy, generate artwork, or help draft presentations. All of this is powered by generative AI models. So far, everything we have described is generative AI. You will write a prompt in natural language, AI understands your intent, and it generates a response. Could be a text, could be an image, or could be a code. But at this stage, AI is still reactive. It waits for you to ask something, then it answers. Agentic AI is what happens when you take generative AI one step further. Instead of just answering, an AI agent has a goal. For example, prepare a weekly project state user report. An agent doesn't just write text and stop. It uses generative AI to understand the request, read messages or document, summarize key information, and decide what to do next. Maybe also it generates the report. And finally, can ask follow-up question if something is missing. So the difference is simple. Generative AI creates content. Agentic AI uses generative AI to plan, decide, and act. You can think of it like this. Generative AI is the brain that can speak, write, and create. And agentic AI is the assistant that gets things done. And this is why generative AI is the foundation of agentic AI. Without generative AI, agents couldn't understand language, create plans, or produce new content at each step. Now let's look at how language models understand text at a conceptual level. Under the hood, modern language models are built using transformer architecture. You don't need to know the math, just the idea behind it. First, language is broken into tokens. Language models don't read text the way humans do. Before anything else, text is broken into small pieces called tokens. A token can be a full word, part of a word, a punctuation, or maybe a small group of characters. So a sentence isn't processed as a sentence. It becomes a sequence of tokens first. The second step is changing tokens to embeddings. The model still can't work with words directly. Each token is converted into numbers called an embedding. Think of embeddings like points or arrows in a multidimensional space like you can see in the slide. Tokens with similar meaning point in similar direction, and tokens with unrelated meanings point far apart. For example, we can see dog, puppy, and cat end up close together, whereas dog and skateboard are far apart. This is how the model represents meaning through relationship, not definitions. The third step is where the transformer model comes in. The transformer is the architecture that takes token, looks at their embedding, and decides which tokens matter most to each other. It does this using a mechanism called attention. Attention means the model doesn't treat all tokens equally. It weights some tokens more than others, depending on context. For example, in the sentence, I heard a dog bark, when predicting bark, dog and heard matter a lot, and I and matter much less. The transformer uses attention to assign importance weights to tokens. Those weights influence the embedding in that moment. So the key idea is embedding represents meaning as position and direction. Attention adjusts that meaning based on the context, and the transformer architecture coordinates the process. Language models don't generate full sentence at once. Using the transformer, the model starts by looking at the existing tokens. Then attention weights what matters. This helps predict the next most likely token. And finally, that token is added and the process repeats. This combination of token, embedding, attention, and the transformer architecture allows models to understand context, generate natural language, adapt response dynamically, and power generative and agentic AI systems. Up to now, we have talked about generative AI and language models. Systems that can understand language and generate text, images, or code. Now we are moving to the next step, AI agents. And the key idea to remember is this: an agent is more than just a model. Let's start with a simple comparison. When you ask a model a question, you get an answer. For example, summarize this document. The model reads the text and generates a summary. It responds, and then it stops. That's powerful, but it's still reactive. Now compare that to an agent. When you give an agent a goal, it doesn't just answer. It tries to get something done. For example, you ask to prepare a weekly project statue update for your manager, for example. An agent understands the goal, decides what steps are needed, and then acts. This is the fundamental shift from answering questions to completing tasks. An AI agent has three core components: a model, instructions, and the tools. Think of the model as the brain. At the core, an agent uses a generative AI model. This is what allows the agent to understand natural language, reason about requests, and generate text or plans. The model gives the agent its language and reasoning ability. The instruction is the one that helps defining behavior and boundaries. Agents don't act randomly. They have instructions that define their rule, what they are allowed to do and what they should not do. Think of instruction as the agent job description. For example, we can give the clear instruction. Let's say we're going to say you are project assistant, you help summarize information, you don't make final decision. This is how we ensure autonomy within clear boundaries. Then tools is all about taking actions. What truly sets agents apart is tools. Tools allow agents to interact with the world. There are two main types: knowledge tools that helps find or retrieve information, and action tools that helps to perform tasks. For example, searching documents, sending emails, or updating calendars. With tools, agents don't just talk, they act. Agents are not here to replace people. Instead, they collaborate with humans. You provide the goal, the context, and the final validation, where the agent gather information, suggest actions, and automate repetitive steps. Think of agents as digital teammates that help you work faster and smarter. Agents don't have to work alone. In multi-agent systems, different agents specialize in different tasks. For example, one agent gathers data, another agent summarize it or analyze it, and the third prepare for a full summary and take actions. Together, they form a workflow similar to a human team with different roles. Now let's do a quick exercise where we will experiment with generative AI models. We can also practice this exercise by accessing the lab steps in the link that you can see on the screen, or by visiting the AI-901 learning path through the Microsoft Learn platform. Let's go. In this exercise, we're going to try a little bit to play around a chat playground, where we're going to interact a little bit with generative AI model and explore how it could be used to support an employee expenses agent that helps employees with expense claim policies and process. For that, we are going to access the aka.ms/the chat-playground. You can also access this through your browser using the exercise that you can find in the Learn platform for the AI-901 course. So to complete this exercise, you need obviously a modern browser on your computer with sufficient hardware resource to load and run the models used by this chat playground model. And also, you may need a GPU to do exercise faster, but still, if you don't have a GPU, there is an option with the CPU, but it is really much slower when you work with the CPU. So it can run successfully with the CPU, but it's much slower. So as I said, it's going to be running on your computer using your resource. So it's basically a web GPU or based on your Microsoft V2 model using your own CPU resource if you don't have a GPU. So all you have to do is to wait the model to be downloaded to be able to use it. So now here my environment is ready. Here you can change it to maybe a more darker mode if you prefer. So I prefer darker mode, so I'm going to put it in a darker mode. And as you can see here, we have specifically a playground that looks like a playground that you're going to work with when you work with agent. So we're going to start with really a basic prompt. What is expense management? So sending this prompt is going to give me a general information from the web. Expense management, also known as expense management and reporting, EMR, refers to the systematic process of managing, controlling, and tracking business expenses. So it's really basic, general purpose or general information that you can find on the web. As you can see, this is the answer that we get from AI, a really long answer, really general answer that information that we can get from the web. So this is because the instruction here that we are giving to the agent is, we are just saying you are an AI assistant that helps people find information. So if you want the agent to provide shorter information, concise answers to expense-related questions, I'm going to specifically say that. So in the instruction, I'm going to say, you are an AI assistant that provides short, concise answers to expense-related questions. And in this case, it's going to change, okay? So this is what we call system prompt that I use to provide the model with an overall context of its response. So you can use the system prompts to provide guidelines about the format, style, and constraint about what the model should do and should not do when it gives you an answer. So moving further, I'm going to follow this. So if I ask the same question, so I provide, here I put a new chat, and I ask the same question, what is expense management? So here you can see the answer is much shorter. So expense management is the process, etc. So few words, it'll give me an answer. I can ask more questions. For example, tell me about per-diem allowance. So tell me, this is a predetermined daily payment given to the employee or service provided to cover travel, etc., etc. So we can also give like a follow-up question here. How are they reimbursed? So here's we're really asking, referring to the previous question. And AI, generative AI and agent work really well on this, so it keeps the discussion going with you and answering follow-up questions. Okay, you can see here the answer, how are typically reimbursed through an expense management system, software that records the expense, accrue, etc., etc. So provide me more context, more information about how to reimburse this. Normally in a company, if you want to create an expense management solution, you really grounded the response to your company data. So generative AI is really the foundation of agentic solutions, so in which AI agent can assist you and act on your behalf. So to accomplish this, agents need tools, okay, that allow them to access specific knowledge and perform tasks as expected. So in here, we are really going to add tools. And in this case, the tools that we are adding is knowledge, and knowledge is going to be a file. And here's we are giving you, like, you can provide TXT files, and that's exactly what we are going to do. Going to upload a file specifically for this that I'm going to use. Okay, so I have just uploaded my expense text.txt that provide information about how to do the expense in this fictive company that we have. So I can now ask a question. So conversation was restarted automatically to follow the information in the file that we provided. So I'm going to ask it here, how do I submit claim? So I can see here, to submit a claim, you can send to expense@contoso.com and give me a reference to the TXT file. So I can also ask other questions like how much can I spend for a taxi or for a hotel. I'm going to answer specifically from that document. So you see here $75 per taxi, ride share, and I reference that file. I can ask it other things like, what about a hotel? So also, again, give me the right information. So that's about this here. You can see also here in the model, you can also play on other parameters. So you can change a little bit the temperature, which is going to control the randomness. So the lower is more focused and higher is more creative. Also, you can change the top P that is going to control the diversity of word choice. You can also control the max tokens, which is the maximum length of the response. You can also put a repetition penalty that's going to reduce the repetitive text, and higher value is going to have less repetition. So you can configure this and until you have the right parameters that works fine with you. Now we're going to move away from this. We're going to go to see really models and agents that can be used in pre-provided chat playground. And we're going to really look how we could work with the developers, work with them to build applications. And for that, we are going to access the aka.ms/model-coder. And this is going to provide us with a playground. We're going to really look into the code part. We're going to really work on a code part. Here's when you load it, it may take you a little bit of times to load the first model. Here for us was fast. You can see here also we have GPU, CPU. You can start with a blank page or base simple chat or other pre-configured like chat completion code that you can work on it. So let's start with an empty page. And I'm going to edit it to put my piece of code. I'm going to put my piece of code here in the editor. So this piece of code, what it does, it's going to help me to really to implement a simple AI agent and can help you categorize expenses. So that's what this piece of code does. So if we start here, we can see import namespace. So here we are using from OpenAI, import OpenAI. It's really good to try out, to start like using, try out. We are providing the endpoint, the key, the model name. So we have a local LLM that we are using. Here we have the OpenAI client. You can see we are using the URL, which is this endpoint. We are using the key, which is this key. And then we are here working with client response. Okay, so we are doing OpenAI client response create. We provide the model and we provide instructions. So here our instruction is you are an AI assistant that provides short, concise answers to expense-related questions. And so also we have here the input text that we are grabbing to really the prompt itself that we are going to get. So here's where we are getting the information. So input text is input agent enter question about expense. And you put your question. So once we are happy here, we can start out. So we can execute the piece of code. We are in the terminal. We can provide our first prompt. So I'm going to paste here my prompt. So you can see here, agent, enter a question about the expense. That's here what is seen it in here. I'm going to myself asking the question, what is a purchasing card, for example? I'm going to execute the model locally and provide me with an answer. Now we have an answer from the agent. A purchasing card, often called a P card, is a financial tool issued by a company to its employee to make business purchase, and you have more information. Can keep asking more questions. You can see here that we really used the local LLM. Here we are using a small language model with really limited training data and small context window. So the response may not be really accurate for you, but that's totally fine. So just like small model, easy things, etc. Well, that's it for this demo. In this demo, we have explored like a generative AI model, chat playground. We have seen how models respond and can be also affected by changing the system prompt. And so also we have seen how to configure model parameter and how adding data is going to change things. And we have explored also how developer can actually build a generative AI client application through OpenAI compatible APIs Python. In this session, we discussed generative AI and how it evolves into intelligent agents that help us in our everyday tasks. Remember that all these materials is available for free on the Learning Path, and you can find the full Learning Path at the Microsoft Learn platform. This concludes our session. Thanks for joining us for this session. To continue your learning, we encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. Happy learning!